Hello, all. Welcome you all for this End-to-End AIML program where we're going to learn everything from scratch, to become a successful data scientist. So for this, it is going to be a year-long program. So please subscribe to our channel to get all the videos that we are making on this AML. And please subscribe to our channel and then just click on the bell icon so that you not miss any notifications. And if you guys have any doubts, just ping in the comments and we are here to help you. Okay. So we are just learning about data wrangling. Okay, so in that we'll just jump into it. So it is going to be a second session of data wrangling. There is a previous session. Please watch previous session so that we can you can have an understanding of what we are teaching. Okay, so now we're going to see EDA. It's an exploratory data analysis. It's a part of data wrangling. Okay, so first is summary statistics, like calculate descriptive statistics like mean, median, standard deviation, quantities, quartiles to understand the central tendency and spread of data. So this EDA helps us to get the statistical summary of the data by calculating its mean, median, standard deviation, and what is a quartile range, first quartile, second quartile, and third quartile, and then something called as a central tendency. These are called as central tendency. And whereas it is also helps us to find the spread of data, how the data is spread, whether it is in the mean itself or then it is further splitted from the mean. Okay. Next, we're going to see data visualization. You can create charts and graphs to visualize and expose the data, and then we identify the patterns, outliers, and relationship between the variables. So we go for data visualization, the meaning we can able to find some outliers and also how the data is. Okay, we can identify the patterns and trends. Okay, so it is helps us to find the relationship between the variables also whenever we visualize. Okay, next is feature engineering. It is a form of transforming existing variables into a new feature that are more relevant and informative for the analysis and model building. So this is a major thing. You will be having some lots of existing features. So by combining that, you will create a new feature which will be very important in order to just work on creating a target value. So guys, make sure that this feature engineering is also an important thing. Like it is creating a new feature by using the existing features that are available. Okay, so this is one of the type or technique that we are available in data wrangling. So yeah, that's it from it. So yes, sir, over to you.
Yeah. So EDA, we need to understand, guys. We need to will understand the summary of statics, calculating descriptive statics such as mean, median, mode. We need to and standard deviation, quartiles. Okay, and central tendency, spread of the data. We need to understand that summary of statics. Then we have data visualization, creating charts, graphs, visual exploration, data patterns, outlier, relationship between variables. That's how we'll do. We'll understand data visualization through these concepts. And then we have feature engineering, transforming existing variables into new features that are more relevant, informative for analysis and model building. So this is the overview of when you talk about EDA in data science and AIML. So summarizing statics, data visualization, feature engineering. Let's move to the other session. Sorry, other slide.
Yeah, sure. Yeah. So data transformation strategies, guys. So we are having different data transformation strategies. Okay, as we are mentioning, right? So we cannot just directly go and use the data for the model because model cannot understand. For us also, we need to it should be in a form that we can understand. Okay, so in order to make the model can understand, we should make the data in a manner that model can diagnose. Okay, so for that we are having different data transformation strategy. We will see one by one. First is scaling. So transform data to the common scale such as standard scalars or to normalization to improve model performance and avoid bias. Okay. So we have just listening to this lots of time. We need to scale our data. So consider we are having a single digit number in one column and then a 5 digit number in another column. As a human perspective itself, we will give more importance to the column which has the 5 digit number. Okay, the model also learn in that manner only. So in order to avoid the bias, to make the single digit number column and the 5 digit number column same, we need to make it standardized. Okay, by using scaling method, different scaling methods are available. We will be using something called as non-max scalars, min-max scalars, standard scalars. There are different things available. Okay, everything has some range, 0 to 1, -1 to 1, -2 to 2, like those things. Okay, so scaling is one of the method where we can go for data transformation strategy. Okay, next we are having encoding. Okay, converting categorical variables into numerical representation such as one-hot encoding or label encoding for use in machine learning models. So consider, so we are having heart disease prediction data set, right? The person has heart disease or person doesn't have heart disease. It is a sting like kind of thing. So what do you need to do means you need to go for an encoding. Encoding is what? If the patient doesn't have a heart disease, it's going to be zero. If the patient has a heart disease, then it's going to be one. These zeros and ones only feed to the data set, and now it is encoded. Now the machine can understand because we did zero and one. Earlier it is string, now it is zero and one. So this is how the machine can understand. So you need to go for encoding. This is why we need encoding. Next is feature engineering. Actually, we have just now seen in EDA. Create new feature from the existing ones to capture more information and improve model accuracy. The thing is, whenever you need some new feature by using the existing feature, you need to just club everything and then do some kind of processing, and then you create a new column, which is very necessary for the target value that you are looking for, and then for increasing in the model accuracy. Then dimensionality reduction. So reduce the number of features in the dataset while preserving the essential information using techniques like PCA, LDA, principal component analysis, linear discriminant analysis, and then TSNA. So like different type strategies are available. What this dimensional reduction is saying, like, consider we are having 1,000 features, okay, in order to build a model. So if I train with this 1,000 feature, what happens means it's going to be very time consuming and also very computationally very heavy. So what I will be doing means I will apply this PCA and I will say I need just five components, that is five features from the 1,000 features that I am having, so that uh, we will be removing this 995, only we are having five features, and at the same time they are very important to find the target when compared to the all 995 features, okay. So this is how we can do dimensional directions from a high dimension to low dimension and making things very easier, and it is timeless and then also computational less. So these are the way that how you can transform the data, okay. Yes sir, over to you.
Yes, so data transformation strategies. We need to understand uh, how to transform. Transformation means transforming from one state to another state. So, what are the strategies for data to transform it from a normal data to a good performance data, a data which will give us great insights and build great models and solve problems? That's it. That's what means transformation, and that's why we use different features. So the features are scaling. We transform data from common scale, such as standardization, normalization. These are the terms of statics, standardization. We standardize, we bring it to one scale. Normalization, same thing. We normalize the data. Okay, we bring to same pattern so that we can get better, we can improve the model performance and avoid bias. Okay, so I'll give an example. Somebody is saying uh, the price of house is X, somebody else is saying Y, somebody else is saying Z. So we have to normalize it to either X, Y, or Z for the entire data, because we have to bring it to one scale. We can't have three different standards, then your model will be biased and it will not perform well. So that is what is called scaling. Scale you have seen in your house, you will have scale you have used in your school. That is what it is. Actual concept comes from there, because you can measure anything with that scale. Standard is scale. So we do standardization and normalization. That's it. You don't have to worry about all these fancy terms. Huh? Just understand the concept. Then then we have encoding. We convert categorical variable into a numerical representation. Okay, and such as one hot coding. Okay, label encoding using in machine learning models. Like we make it true or false, zero or one. We do such kind of, we will make it, it's also called kind of, you also do some kind of normalization. You bring it to a normal, you bring it to a scale, you bring it to a level where model can easily, because see, ultimately our computers are they understand 0 and 1, guys, binary, right? We have, right now we don't have quantum computers. So quantum computers, we have bits 0 and 1 in computer. Normal our computers right now, whatever we are using, even the supercomputer. Then when we have quantum computers, we'll have qubit. Qubit has superposition. It can be here, it can be there, it can be here. There you have multiple variables. It can measure any, but right now our computer has limitation. It can understand 0 and 1. That is why we have to do standardization. We have to do normalization. We have to do encoding. That is why. Otherwise, for a quantum computer, it can interpret any kind of data because it has superposition, right? Superposition is that it can be at any position, it can measure anyways. That's why quantum computers can do billions of transactions per second, less than second. So it can huge amount of data it can process. So feature engineering, creating new features from the existing ones, okay, uh, okay, and more information and improving the model accuracy. Then we have dimensionality reduction. So what we do is we reduce the features, like we reduce the features through PCA, okay, we preserve the essential information, and we reduce the some features which are not relevant. If they are relevant, we keep it. If they are not relevant, then we do dimensionality reduction. We reduce the dimensions. So dimensionality reduction means we reduce the dimensions which are not relevant. Which are relevant, you should not. Otherwise, your data will again become biased. Okay. So be careful about that. Thank you so much. Let's move to the other slide.
Yeah, sure, sir. Okay. Next, we are having automatic data wrangling flows. Okay. So first thing, what are the benefits and what are the uh, increased efficiency and then reduced errors and then improved consistency. So that's the thing. So we will be having tools. Okay, so we will be having tools like in Python. We are having some tools like scikit-learn, pandas, like those things which will automate this data wrangling process. And or we are having or like, so in or also there are different packages like dp lyr package and ta dyr package. These are the things that will make this data wrangling very easier. Okay. And something like cloud-based data platforms. Okay, it also makes this data wrangling very easy. We need to just use the packages and tools which are available from the cloud, and we can use it and make things very easier. So the benefits are it increases the efficiency, reduces error, and also like it improves the consistency of data. And the tools which we can use it for automating it like Python or and then some cloud-based tools we can use. So these are the way that we can automate this data wrangling process. Instead of going for a manual process, we can automate it. Okay. Yes, sir. Over to you.
Yes, guys. So automating data wrangling workflows. So how we do automation, like automating automation is, so we have to understand the concept. The benefits tools, like increase efficiency, Python libraries, Pandas, scikit-learn. Those are the tools which we can use. Okay, reduce errors, R packages we can use, okay, and then improved consistency, cloud-based data platforms we can use, okay, to automate data wrangling workflows. Okay, let's move to the other session.
Okay. So the next slide. Yeah, guys. So what is the end goal of this data wrangling? For like we are cleaning the data, doing transformation, doing filtering. Just just think, what is the end goal? Okay, data quality and then integrity. Okay, these are the end goals of this data wrangling process. First is data validation. We need to implement data validation tool to detect and prevent errors during data entry and then process. Okay, so we need to validate the data. Whenever we are having a data, we need to validate it before we are just passing to the pre-processing itself. Okay, whether this is the data I'm gonna work on. So that's a question that you need to ask. What is the data? How data comes, and then where it comes, and what we gonna do that? Okay, what we gonna do with it? Okay, so these are the different questions that you need to ask before you going for any kind of model building. So that is what the data validation. Next is data auditing. Regularly audit the data to identify and resolve inconsistency, ensure data integrity, and maintain the data quality. Okay, regular audit. Okay, you need to if there is a live data when you are working on a stock market data, you need to be regularly updating the data. So you guys need to have an understanding of whether the data is consistent. So guys, you should not use a previous year data to now to like predict the next month result. Okay, you need to use the previous month results, and then we need to go for a next month, and not like 2 years before, 3 years before, or 10 years before data to predict the stock price of the tomorrow's data. Okay, you need to be very very well versed with the current scenarios, current data that you are having, so that it will be more accurate. The prediction will be more accurate. Okay, next is data security. Implement security measures to protect the data from unauthorized access, modification, or detection. Guys, actually, till this stage, there is not, I will say, there is nothing called as 100% secure. But client will always look for some solutions which are local rather than cloud based, because whenever we are going for a cloud based, their data going to be exposed to the cloud. So client, no client will be happy to make their data exposed to cloud, yeah, for the public audience. Okay, so data security is very very important thing. You guys need to secure the data in some manner, like on a kind of encoding or kind of crypto, anything. Okay, or some ciphertext, anything. But you need to go for data security. That's a very very important thing nowadays the people are looking for. Okay, even though we are creating a chatbot by using LLM, the now the companies are looking for some private chatbot that will not read their data. Okay, they are having that much sensitive data, so it should not read, and it should not remember, and it should not recreate whenever it is created. Okay, so the data security is very very important, guys. Okay, next is data documentation. Maintain clear and comprehensive documentation about the data, including its source, structure, and transformations, to ensure transparency and facilitate future use. Yeah, it's a major thing. So whenever you get a data, you need to document it. Okay, where I have get the data, how much data I've got, when I have got, how much I'm going to use, and where I'm going to store. Like those things, you need to have a documentation, so that anyone who doesn't know about it, the data collected, they can understand, and for us also in future it will be very useful. Okay, if we are collecting more data, then we will not keep track of all the data. So yeah, this is all about ensuring data quality and integrity. It includes like data validation, data auditing, data security, and then data documentation. Okay, this is all about how we can ensure the data quality and integrity. Yes sir, over to you.
Yes, guys, this is very, very important. So, guys, this is we are me and Raja, we are doing this like why we are doing reinforced, and we are bringing different perspectives so that you can absorb information properly. And once you absorb information, which is input, and then you digest, which is function, then you go and apply, which is output. So again, this is the principle, right? There's a methodology why we are doing this, and you check across YouTube, on everywhere in the world, nobody does this way, because we are doing reinforced learning kind of methodology, and we are bringing different elements, and the way Raja is giving perspective and the way I am giving. So when you do it fast, see, when we watch any video, any lesson, we don't retain it. Main thing is, the main objective should be always to retain the information and concept. So when we bring reinforced learning into it, so when I give perspective, and we do like, it's a dialogue thing kind of thing, and it's like podcasting kind of thing. We are bringing that perspective, and you check across YouTube, you will not find this kind of flavor and kind of energy, and the perspective and ideas. You will check anywhere, even you check Harvard University, MIT, you will not find this kind of engagement. Two people talking like a podcast thing, discussing, and and asking you for feedback so that we can improve more and more, huh? We are ready to improve 1000%, guys, but you should tell us, okay, and subscribe the channels. So ensuring data quality and integrity, guys, it is very very important. Stillness, bring in your personality stillness. Once you bring stillness, the answers are there in the question, guys. 90% times the answer is in the question. Are you able to see it that way? That is the main perspective. Ensuring data quality, what is ensuring, what is data, what is quality and integrity. So that means you need to do data validation, because you have to The objective is quality and integrity, yeah? And implement data validation rules, detect, prevent errors during the entry or processing. So when you are collecting data, you have to keep this thing in your mind, that you always validate data. Is it biased? It is not biased. It is from the right source. All those things. And implementing data validation rules, detecting the errors, preventing errors during the data entry and processing. You have to understand it. Then data security, implementing security measures, so encryption, protection, data from unauthorized access, modification or deletion, having proper what I'll say security layers. So if you have in organization, uh, suppose employee layer, they should have only access to certain level of data. Okay, they should not have access to deleting. So somebody should not. If you are trainees in your company who are just trainees, who are not proper employees, so you need to give certain access to them. Management, top management can have access. And same ways, according to the role, according to the responsibility, and ensuring the backup of the data also, because if sometimes somebody did some mishap happened, so your data should not get deleted. You should always have backup for the data which you have collected. You have spent millions of dollars on that data, so data security is very, very important. Then data auditing, regularly auditing data, identifying, resolving inconsistency, ensuring data integrity, maintaining data quality, consistency, and all the parameters. Quality is a very big term, guys. Don't just think quality from your perspective. Quality has multi layers. Suppose I'll tell you a Toyota car, they are the major, they are the in Lean or Six Sigma. If you've gone through, so they have invented Lean and Six Sigma. I have done projects and all. So they Toyota, even when you the softness of seat cover is also quality. It is end to end. There are thousands of parts and thousands of uh, perspectives in the Toyota car, right? So they care about each and everything. Even if one thing is not right, the entire quality of product is degraded. So understand quality not from one perspective, but 360-degree consciousness. When you're developing any product or service, any application, any project, you have to understand end to end 360 degree about quality. Okay, then data documentation, maintain clear comprehensive document about whatever changes you have made, upgrade it, write in the comment, make the documentation, so that the other person will also get to know. If you resign from the company, the other person will not have problem. So the management team is informed. So always maintain the documentation structure, um, transformation to ensure transparency, so that it facilitates future use, right? Documentation is for future use. Tomorrow 10 employees have been, like, your team, entire team is like they've resigned, so somebody else will come, they have to start from scratch because they don't know, there's no documentation. Management will not have perspective about it, nobody knows. So that means that is very, very crucial. Even if you have organization and somebody does that, how you will feel. So you have to have empathy, you need to have that feeling that the other person will see this, and my whatever, whether you are working for one day or entire life, have these rules for data quality and integrity. And thank you so much. Subscribe to our channels and absorb the information, digest the information, apply the information, and subscribe to our channel and also bell icon, so that you will get notification for each session. Okay, this is year-long program, and after that we are going very deep. Even till now, no university in the world would go that deep. We are designing another next level program where you will understand from an axiom and the premise, the fundamental level, that how these black box functions and things work in AI, ML, and data science. So that's a next level. First, let us do this properly for 1 year, and then we'll come to that. Once we complete this milestone, then we be there. But be connected, stay with us. Write in the comment section, connect at nobletransformation.hub.com, so that we'll be always there, and subscribe to our channels. Thank you so much. Let's see you in the next session.
Yeah, guys. Bye. We will see you in the next session. Bye, guys.